well, it's my first time in Armenia, and it's a pleasure to be here and see so many people. I really like Armenia. I'm from Ukraine myself, as you can guess from this small flag in the corner. So I'm proud to be Ukrainian, and yeah. Let's talk about some AWS, right? Okay, a couple things. Well, before I begin talk about main stuff, uh, please listen carefully because best question will also get one of these two books which I have, Terraform in depth. It's not book written by me because I'm lazy to write books. I just wrote 4 words to this book, and I think it's pretty good if you are learning Terraform and you want to know a bit about good practices and not necessarily about AWS. So ask your question at the end, and then we'll probably decide, or maybe I will decide the best question, and you will get the book. So my name is Anton Babenko. I'm AWS Hero. For the last 10 years, I've been quite active in Terraform and AWS communities. Some of you may know what is Terraform, right? Who knows what is Terraform? Excellent. Oh my God. Then why are you all here, guys and girls? Okay, jokes aside, I like to contribute to open source, and many open source projects listed here helped a lot of companies and a lot of people to be productive. That's pretty much my goal. I want to make this talk not about technologies or something what I develop, but I also want to make you be interested in open source technologies, in architecture, in different cloud capabilities, and so on. I spent quite a lot of time thinking about different open source projects, especially from around 2017 or up till now. I spent a lot of time talking to different users, try to figure out what's working, what's not working. So over the period of time, I came up with a project called serverless TF, which I will be talking about in more detail later on. But also I wrote Terraform Best Practices as a set of best practices when it comes to managing infrastructure. So if you in your company use Terraform and you may think that it's still a place for debate, and you may have some things which are not known, or you don't want to argue with somebody, just read this book or give this book to them. It's translated to more than 20 languages, but I'm pretty sure Armenian is not in the list. So if you want to translate it, it's open source. Just reach out to me, and you will get right access to Armenian section, and it will be cool to be able to popularize it among Armenian community as well. So if you like to watch YouTube, well, who doesn't like to watch YouTube? And this is one more channel where you can learn about Terraform. I spent a lot of time talking to different creators of different tools. I like to do different tools review, which I find relevant for people who are into Terraform community, and I really want this community to grow. And I also enjoy doing two things at once. While I have to maintain some open source projects, I also like to show how I do this. So this is so-called live coding, where I read pull requests and I complain about author. Sometimes I merge it, but usually not, because there are a lot of bad things happening in the code. So I just blame author and then move on to the next issue. That's unfortunately a very frequent experience, because there are not many things which can be added. And that's really important to understand. So yeah, I will be here the whole day, so we can talk about this forever. Okay, one more project is Terraform Weekly newsletter, where I have more than 12,000 subscribers. Every Wednesday I go, well, actually every day I go online and find different interesting pieces of content. And every Wednesday I send out a newsletter where I include something like 5 articles. These articles, very important to understand, are not a repetition of the documentation or something very well known. I usually like to focus on something what is educational, even for myself after so many years doing this. So I really spend some time thinking about, okay, what is actually new after so many years in this field. So feel free to leave your email, or if you still know what is RSS, raise your hand if you don't know what is RSS. Come on, 10 people. You see, Jeff was asking who is using different kind of 0 and 1 and assembler and so on. My scale is people who know what is RSS, the really simple syndication, and people who don't know. It's not a bad thing, but yeah, it still exists. So Terraform AWS modules is essentially just a collection of more than 50 open source, Terraform AWS modules. It's a set of projects where community contribute and community get significant value when they when they want to manage infrastructure using Terraform on AWS. So all kind of modules like VPC, EKS, and RDS are very well supported, and a lot of users appreciate it. What we try to focus is we take services and we try to figure out all possible combinations of what can be configured, and we provide reusable components, which is very important to understand that these modules are not something what is just suitable for just one company because lots of things are hard-coded. No, that's not the case. We always allow to parameterize a lot of things, and we provide a lot of different examples how things can be configured. And we also pay significant attention on maintaining it as quickly as possible. In the past, we had a lot of day zero support for many features because we were lucky enough to have many users who were eager to use this stuff right away. So as soon as something was released by AWS, then Terraform AWS provider got supported, and pretty much in few hours we got supported in the module. So this is open source. You can think about this as nice and sunny and everything is fine. No, it's actually not true. Thanks to these sponsors who sponsor my work throughout the years, and this is probably not all sponsors, but I really appreciate that people are not just opening issue or sending me message through chess.com while I'm playing chess, because it's quite easy to find my username. You can guess my username, right? So instead of that, they actually figure out that we can actually support you, and they become sponsor. So some people buy coffee, some people sponsor for more. So open source is like, yeah, okay. Eventually, AWS realized that there are official ways to getting started with serverless on AWS, right? There is serverless application model, which AWS developed themselves. Then there is CDK, which again, very popular way to manage infrastructure. Then there is serverless framework, which again started because it has name serverless, so it's probably used for serverless infrastructure. And then after a couple years of me sending emails to different marketing people and saying that I have started this project and it's already quite active and a lot of people use it, and they replied to me, yeah, but this is just your hobby project which you will kill tomorrow, so we don't want to put traffic into it. So a few years after, they actually made this significant change. To my mind, it's significant because AWS realized that it's actually important project and people use it. So I was very happy to see this one, and yeah, that's good to be there. So I mentioned a bit things about serverless, but should we even like describe or talk about what is actually serverless architecture, right? Yes or no? Yeah, let's go. Okay, that's a good statement. So here is a diagram of sample serverless architecture. As you can see, it's pretty straightforward from the user perspective, where user just reach out some API gateway, and then API gateway dispatch request to one of two Lambda function. If it's going to be post request, then it's going to handle it as a write Lambda, and data will be stored in the DynamoDB table. If it's get, then it will just scan all items from DynamoDB, and that's it. Job is done. So very simplified architecture. The important aspect here is that what makes it serverless? Well, to my mind, the most important aspect is that we need to use a lot of managed service provided by AWS and focus on just our application code. I've been doing software development pretty much all my life. Yes, I'm old. Well, okay, maybe not so old, but at least I've been doing it for a very long amount of time as web developer and a system developer. And then when I have heard about serverless, like for the first time, about Lambda, about the promise that all you need to do is just write your application code, the rest is managed, or maybe it's not so much as I'm saying about it now, but the whole point is that I want to focus on my application code. That's, again, a huge benefit to me when I have heard this for the first time. And why it is so important is that in order to make a good solution, we need to compose it with pieces which we can easily comprehend and can easily understand. And I'm not talking about any other like level of abstraction which we can use just to hide it. I'm talking about that if we can write our code and think about what this code does, it will be very efficient and very good quality. So when it comes to the rest of infrastructure, well, we can think that we have our application code which will be deployed to Lambda functions, and the rest is already managed through Terraform, which is normal AWS services, right? We already use Terraform for that. I saw some hands, so people use Terraform, which is a good option. But let's talk about different available options when it comes to serverless specifically. So we can use some default things for serverless, like AWS SAM or serverless framework. These options exist, and they're pretty powerful. Of course, all of these options always have some trade-offs, but we are not going to talk about this now. We think about this as a default, right? Because, well, they were designed to be serverless application models. They probably do some for serverless, and they do. When it comes to managing infrastructure, we have, again, a bunch of different options which we can choose from. We can use, typically people on AWS have heard about CloudFormation and CDK or Terraform. Again, we have at least 3 different options which are widely spread. And when it comes to ways how we can deploy our applications, what we can typically do. Again, we can use different managed services like AWS Code Deploy, or we can script it the way we want using AWS CLI, or using different shell script or make files. Deploy.sh, like, is still a viable option, right? Who hasn't deploying anything using deploy.sh script, which does hundreds of different commands in one and then fail in the middle? It still exists, right? This option is still there, and it's really important to understand that whatever we choose, we will periodically go through Yakshaven, and there will be infinite amount of rabbit holes, right? We plan something to spend 2 hours. It never takes 2 hours. It takes 2 days. With some conditions, it may take even more days, and so on. So we always need to understand that there is no one option which fits all. But what I like to think about this, and that's what I was thinking when I was designing serverless TF in the first place. When COVID started, I had probably nothing else to do. So I was thinking like, okay, let's make this stuff happen, because it was very hard to manage serverless on AWS using Terraform. And people still now believe that it should be hard because, well, if everybody else is struggling, there has to be a reason for people to struggle. Let's support them. This Stockholm syndrome has to be ended, I decided. So I looked into important aspect while designing this solution, that in order to build, deploy, and manage, we don't have to use pretty much anything else than just Terraform. So we always call not deploy.sh, which does 100 other things, and we somehow orchestrate it. We always use just Terraform CLI the same way as we normally use it. So the outcome of serverless TF, which I will demonstrate in more details, is that we have all variety of decoupled modules for various tasks. For example, for packaging, for building, for deploying, we can use, we have module which supports all of this. And currently, Lambda module is able to handle all Lambda-related tasks, including deployment with different strategies, packaging, deploying through containers, and building in Dockers, and many, many other things. So ultimate goal, once more, is when you want to manage Terraform, when you want to manage serverless architecture on AWS with Terraform, you should separate that. You write your application logic using whatever tool you like, your favorite programming language, your IDE, your AI capabilities, whatever you want. But once this is done, then you just run Terraform to manage everything else. And Terraform can call different other shell script, different Python script, whatever is necessary to package it and to deploy it and do the rest. So if we look into one of the important aspects of like, you may think like, yeah, but I can do all of this myself using just Terraform. Why should I even consider using any other solution for that? If I want to implement simple pattern where API gateway is calling Lambda function, using plain Terraform, you will have to implement it at least using these resources. So you need to create a lot of API gateway resources, like configure each property. Then you need to create different IAM role to allow API gateway to call Lambda function. And on the Lambda function side, you will have to somehow make an archive of it. You will have to make Lambda function, and again, have a lot of work when it comes to allow secure access from API gateway. So in total, it will be at least these resources. When it comes to serverless TF solution, serverless TF is just a collection of modules. And you can think about this, that all you want to do is just call two modules. One to call API gateway, and another is to call Lambda function. And the only intersection between these two modules are connected as normal Terraform relations, where you say that API gateway route has to call this Lambda function, and Lambda function allow to be invoked by this API gateway. This is it. That's typical way of building architecture using serverless TF modules. You just find module, you figure out which parameter to pass into one another, and pretty much you're done. Currently, we support most of AWS services which are typically used for serverless architectures. A lot of other services are also supported, but I don't put them here because they are also used pretty much everywhere, like VPC. I mean, VPC or RDS or other services, they can be used not just for serverless applications. We also support a very large amount of Lambda parameters and configurations. We have some shortcuts for Python and for Node.js, but we also support capabilities to build packages using Docker, and we support very large amount of these parameters. If you want to build it for your custom runtime, which is not supported, for example, for Rust, you have possibility to specify different commands you want to run, and it will be job of Terraform to figure out that source file has changed. Let's run these commands. Let's make package of it. Let's deploy this Lambda function, and so on. There is a very good resource which is called Serverless Land, where a couple years ago I contributed Terraform patterns, again, for most common things related to DynamoDB streams or different other services integration. If you want to learn more, please go to serverlessland.com and find it in patterns section. It's not very up to date in general, so if you find something is missing, feel free to open pull request. Another thing which I want to highlight is possibility of local testing and hot reloading with local stack. Local stack is a service which allows to provision infrastructure on your local environment or local machine, which is very important if you're offline, like me, or if you want to save cost. For example, in some of my projects or some of my current projects where I have to test like thousands of different parameters, I really don't want to call AWS API 1,000 times, because sometimes it can be slower, or sometimes it can be just expensive. So local stack allows me to provision emulator of AWS services, and this is the way how you do it. You install wrapper for local stack locally, and then instead of calling Terraform, you call this wrapper. The only thing which wrapper does is it change API endpoint. So instead of talking to public AWS API endpoint, it will talk to your local host instance of local stack. And yeah. Okay, I have pretty much 2 slides left. One is just reminding that you can ask a question a bit later, but hopefully you are not falling asleep, so there will be some questions. I have no clue how much time left, but I really want to show you some demo, right? Who wants to see this in action? Good, good. Still, you're not sleeping, that's well. That's very good. So, okay. Where is my? Okay. Cool. So you can see my screen, I hope, well. So I showed 2 ways to manage things. So one is that I can use real AWS, and we create a bunch of different things in real AWS. So I will create this diagram, and I can show how it's done. Or I can use local stack to run local stack locally, and you will not see anything in AWS console, right? So which one do you prefer? Local, I see. All right, we are at AWS Community Day, and we don't want to see AWS console. Amazing, amazing choice. At least it's not Google or Azure. Thank you. Yeah. Okay, that's good explanation. Right. So So first, I want to show how this looks like. So inside of this folder 2023, I put all Terraform files, and these Terraform files are extremely simple, but they are sufficient to deploy the infrastructure which I showed earlier. So one is API gateway, where I get source from this Terraform AWS module, and I specify a couple routes. One get will go to to one Lambda function, and post will go to another Lambda function. Then there is DynamoDB table, which has very minimum amount of properties where just ID and name are configured as attributes, and the hash key and range key. Again, I'm using DynamoDB table here, which is open source, and you can see lots of different examples how this can be configured with a variety of different properties. For the purpose of this demo, it's not sufficient, I think. Okay, so there is also a Lambda module to handle GET requests, and as you can see here, I'm calling just source path will be just this Python script, and I specify that DynamoDB table should be coming from another module, and I also configure that my Lambda function should be able to perform scan operations on this DynamoDB table. Very straightforward, and I also allow API gateway to call this Lambda function. And when it comes to post, it's a little bit more complicated in source path, and the reason for that one is that this function, which is post, is doing a bit more than just scanning. If I look into the source code here, and I can show get function is calling just Boto. Boto 3 is available in. Oh, that's very smart proposal. Thanks. Like this. Oh yeah. Why didn't you say this earlier? Okay, let's start over. No, okay. So Boto 3 is available in Python runtime, so that's why requirements.txt is not needed for that one. But PostPy is using some other dependencies which are specified in requirements.txt, like random name, just because I want to use this library here. And the rest of this code is pretty straightforward. I'm just calling DynamoDB put item method and inserting some records there. When it comes to the way how this post function is built, as I mentioned earlier, that you can specify infinite amount of how this package has to be created. Like there are a lot of different varieties. Here I specify that the source code will be inside of Python function, and pip requirements should be installed. And then in patterns I specify if you like regex, you're my friend. I really enjoy writing regex, but sometimes they look ugly for people who never saw them. Apologies. So here we specify that we don't want to include anything inside of virtual environment folder, and if folder is ending with dist info, we don't include it, just because there is no need to include it into package, into produce package. So now if I run, and yeah, and that's pretty much it. So as you can see, to configure this service, we call 1, 2, 3, 4 different modules, and we have what we need. So now if I run this code, and as you mentioned, you want to run it in local stack, I have local stack running already. And what I need to do, local and init. If I run Terraform local init, it will just download providers and instantiate all the modules. It does. So now if I run Terraform local, tf local apply, it will tell that it wants to create all of these resources, and it should be pretty quick because it's just doing it locally. The only time-consuming thing can be to download these packages, to download requirements, and to make it. So now when this is done, we can see that we have this API endpoint, which looks a bit suspicious, but hopefully it works. And the way how I can trigger this one is that, of course, I can use HTTPS, which is HTTP, and I can specify that I want to use this one here. So what's happening now is that local stack, hopefully, local stack responded, and you can see that this is twisted web, which is definitely not from official API gateway endpoint. So it replied from local stack cloud, and this is the response. New item saved, potential port is the name of this. If I run it again, it says that blistering something. And now if I run get, there will be invocation of another Lambda function which lists all these items together. So as you can see, all of this infrastructure was created in local stack. To prove that it was created in local stack, if I have to, you can see that all of these account IDs are 000 inside of Terraform state, and so all Terraform state is full of example and 0 zeros, which means that it was created in local stack. Cool part in using local stack, especially if you need to do a lot of experiments, is that you don't need to clean up or destroy or anything. It will be just disappeared by itself. So that's pretty much it. Again, I don't know how long time I have. So let's think about wrapping up. And this is pretty much it. That's the whole wrapping up. So please ask questions, and we'll see.
Yeah, thanks a lot for this presentation and really new thing learned today. The question is about, can we see everything in this local stack is going to emulate the AWS, yeah? So can we see anything in the CloudWatch?
I'm not sure if CloudWatch is supported by local stack. I mean, it is probably supported, but capabilities are very different. Like, not all features are available in local stack for obvious reasons. Some features, like API gateway, which I'm using here, requires that you use license. This license is free to get. No, it requires API key, which is free to get. You just open an account on local stack and you get this API token and put it as environment variable. So it's pretty straightforward, but still, I'm not familiar which services are available on local stack, and parity of these services differ. So
okay, thanks.
Yeah. You have question. You are very shy, but yeah.
Where?
No, just start talking. Come on. Yeah.
Okay, so thanks for the insightful presentation. So as you said, the serverless.tf helps us build and deploy applications on AWS, right? It's only for AWS. And we know there's AWS CDK, which does pretty much the same. So I want to understand, why would one choose one over the other two? Like, what are your thoughts on that?
Yeah. Well, I have two answers. One is honest, and one is for recording. So raise your hand if there would be a chance for you to not use CloudFormation. Wouldn't you avoid it? Right? You see. So these are potential users of serverless TF, because there are a lot of people who don't want to use everything where CloudFormation is inside. And yes, you can say that CDK is abstracting away. But
I wanted to say that.
Yeah, but it abstracts away until you hit some limitation. So there are a lot of reasons why people prefer to use Terraform for the rest of infrastructure. And my take on this one is that if you're already staying happy with Terraform for the rest of infrastructure, let's continue making you happy by expanding this horizon and allow you to manage serverless effortlessly.
Okay.
That's it.
Thank you.
But yeah, CDK is definitely widely used.
Hello. My question is, in the real world production environment, how do you keep your Terraform state dry and avoid unintentional resource recreation when orchestrating purely through Terraform? Thank you.
It's not about serverless, right?
No, it's about Lambda functions. How do you orchestrate them
without
avoiding resource recreation and keeping your Terraform state dry?
Oh yeah, that's pretty complicated thing. I still don't know answer on this one. Like in most of my production stuff, I do fingers crossed and I run it, and I run plan, and then I'm almost certain that there will be at least some drift, because this drift is usually not so bad. But in the past, what happens is that there are some monitoring services who, for example, decided to update layer version, or sometimes different source hash ID has changed, while I'm sure that I didn't touch anything in the code. So there are a lot of things which can be beyond your control. Normal practice, not related to serverless or to Lambda, is that you put it into pipeline and you remove human from the loop as quickly as possible. Right, so humans don't run Terraform plan on the machine, and humans are not allowed to force push something just because they want it. There should be some controls in this flow. While this is cool, in reality, there are still a lot of things which can go wrong. The most, specifically for serverless, that's what I'm trying to implement, but it's a bit more frictions that I'd like to have, is to have pipeline where I deploy from Docker containers, and at least I know that my stuff is not dependent on platform where developers will write in code. Because sometimes it can be different, that Linux and Windows can produce different versions. So yeah, this was one thing which we find a bit more.
And the second question, sorry if I may. I saw about REST API. How about like GraphQL? Do you have any modules for GraphQL?
Yeah, we have AppSync module available. Yeah. Again, it's important to understand that all modules which are there were not developed because somebody dropped it to us over the fence and say like, hey, this is awesome stuff, please take it, and from now on you'll maintain it. All modules were developed well, by me or by Brian, who was working for AWS, because we had this need for ourselves. So all code which we develop is in very similar style, with exactly the same ways of interacting, because we wanted it ourselves. When I used AppSync, I checked registry, there was nothing, so I made effort. I made AppSync module and I use it for that project, and yeah, it's still there. People contribute actively. A lot of challenges with AppSync is taken into account, specifically with IAM and service integrations.
Дякую.
Yeah, you're welcome.
Hey, I got a question. I'm here. You can look at me, yeah. Hi, once again. So I want to first of all thank you for the talk. Awesome, very insightful and entertaining. I want to go to the roots of serverless, like to the backbone. Just imagine if you have a project that is written in C++ and has millions and millions lines of code. Would you even consider going serverless? Yeah, that's my question. Thank you.
Well, it all has to start what is use case for this one. Like, who will interact with it?
Who would interact with it?
Yeah.
Like As far as I know, the main approach to serverless is a business logic, right? Approach. So if you want to do something specific with your business logic, you would move to serverless. Who would use it? I don't know, anyone. Like we need a specific goal or specific requirements, to achieve. It's useful. Yes.
I would say that using technology X just for the purpose of using technology X is a stupid idea, right? So what's the whole point of like, oh yeah, let's use this one just because why? Like
because it's easy to use, easy to manage. You can redo really fast, like your samples of codes that are not that big. Like I told you, like millions and millions of codes. When you trying to go, first of all, not serverless, but from a monolith infrastructure, from monolith approach to microservices approach. That's why.
I think that like if you really, now it's Saturday and you have probably nothing to do tomorrow, what you can do is you can take these millions of lines of code, compile it into any runtime. You can run it on Linux and put it into Lambda function. It's pretty straightforward to do. If it has some web adapters or some other ways to be called, it's even simpler. And then you will understand, like, yes, it's quite easy to get started. But as previous lady was asking, that there are a lot of challenges when it is actually already there, and now you need to update it somehow. You don't want to destroy something. Maybe there will be some differences in API which you put on top of this one. So it's a lot of day two operations which you still need to consider it. Mm-hmm. Putting it into Lambda or making it as a zip archive, putting some bootstrap wrapper or whatever is the simplest part. But then you may figure out that it's actually not so cost effective. Which is also sometimes a surprise. Especially, I don't know how frequent is it, how resource demandant your million line of C code. Probably it requires some resources. So yeah,
it does. It actually does. Yeah.
There are a lot of interesting like frameworks which you can use to help you decide whether you need to go with serverless or not. Some of them I think are provided by AWS if you go and search somewhere in documentation. But I usually start with serverless just because I'm lazy to manage EC2 or EKS. That's it.
Got it. Thank you.
Yeah.
Hello? Oh, okay, it's working. Thank you for the presentation. We had a discussion at work recently and I was wondering your opinion on it. Of whether there are specific tasks or scenarios where you would choose CloudFormation over Terraform.
Yeah, sometimes, but it's more like a joke to bootstrap Terraform remote storage. But no, sometimes, well, I have a project which is Terraform AWS anything. Manage any AWS resource with Terraform. And yeah, I gave this talk like 5 years ago just because I wanted to explain how you can actually combine Terraform and CloudFormation as well as many other patterns to manage 100% of resources which exist on AWS. Because as we all know, not everything has API. Not everything is available in either CloudFormation or Terraform or partial support between these features across different tools. So yeah, there are some, there were at least new since 2024, Cloud Control API, which can do a little bit more than CloudFormation. Yeah, it says potentially better support than AWS CloudFormation. I think it still has potential, but I didn't see this potential, to be honest. But yeah, I put it like 7 months ago when I did this commit. Potential is still to be discovered. Yeah, or you can just use Selenium and Puppeteer to click in console. But there are workarounds to avoid CloudFormation. That's what I'm saying.
Thank you.
There are still few solutions provided by AWS when I think solution architects develop some complicated thing. They usually start with CloudFormation, and then you can get this huge CloudFormation file just to understand how things are connected. You can even visualize it just to see what's going on there. But I almost never take this stuff and put it into production, like even on dev or test environment, because it's not flexible enough. I cannot integrate it with the rest of things. So I usually end up with rewriting a lot of this and sometimes leaving like 50% in CloudFormation until I have more time to refactor it somehow.
Thank you for your presentation. As a Java software engineer, it is interesting for me to know about something. So your opinion about this question: are there any boundaries between DevOps engineers and software engineers? So where end software engineers work and where start DevOps engineer works?
Well, I can simply explain how I transitioned into so-called DevOps engineer. I just became interested in how to deploy certain stuff somewhere. I was working with software engineers, and none of them were interested in actually deploying it. And I was like, okay, let's see, what is it? Oh, make this archive and put it somewhere here. Oh, okay. So, and then a few years later, I realized that it's called DevOps engineer. That's it. So it's a very simple way of migrating back and forth. Then, of course, people start to say like, oh, there is SRE. Okay, let's rebrand myself into SRE. All of these titles are irrelevant, but as long as you have interest in anything what you do, you can call yourself anyhow. If you are interested in, let's say, software engineering and you know it well, it's usually not a bad idea to be curious in general in a little bit more than that. Just don't become a full stack engineer where you don't know anything, right? But you can say like, oh, I'm full stack engineer, but don't talk to me about this or this. I know just like React and a bit of how API is built. That's not full stack to my mind.
Thank you.
3 more questions.
Yeah.
Hi, thank you for your presentation and also for work on Terraform modules and support there. I have a question regarding testing Terraform modules. So, as you said, you usually deploy a new feature to providers, to modules, like after a few hours from released in Terraform provider for AWS. But as I understand, like local stack will not support all features. And do you have situation when local stack is failed on testing, and what other test methods do you have for Terraform modules?
Well, first assumption, which I think you have, which is wrong, that I test anything. No, I absolutely don't test anything. I can explain it for 2 reasons. One reason is that when we work on Terraform AWS modules, it's impossible for us to figure out in which configuration they will be deployed. Like one of very old example, when IPv6 was introduced. It was introduced not in all regions at once. In new regions, it was like in Frankfurt, for example, it was a region was launched, but there was no support for IPv4 in that one. So there was already support for IPv6 only, which again, how can I test it? Then newer regions were adding some other features which did not exist in exact same combination in other regions or in other account, or if account was opened before 2022, or if you don't do this or that. Again, all of these things is impossible to predict. So what we heavily rely on is community. We do our best to write code which again works for our setup because we usually need it ourselves. Like there are a lot of people who use it in production on very recent version, and if it doesn't work for them, then we really need to do something because it's like they're the best testers out there. But if it works for them, then we can at least think that people who are not satisfied with the result in their setup, they can at least come up to us and say, okay, it doesn't work in China. Who has access to China? Like, okay, maybe some of you have projects in China. Of course, somebody raised hand. But in general, China is a bit more special. But again, I'm learning about this every day, is that China is special with all services except RDS. I didn't know this until last week, that RDS is very similar, like endpoints for RDS is very similar between China and the rest of the world. So most of this testing is impossible to do, not in local stack, not in like isolated environment, but only for real setups. So the only strategy which I recommend, and this is probably the best advice which I can give to anyone who is asking about testing, is make your pipeline or make a setup where you have really small test environment, which is as close as possible to production by configuration, and try to deploy something there. You will see that your deployment fails, or it can succeed, but then you deploy your application there and something is not working. This is exact, it's not unit test, it's much higher than unit test can provide us, but it's having significant amount of value. So having a different test environment in the same region is incredible. And this is, maybe it will cost a little bit more money, but again, if you are concerned about money, you can look into local stack for some parts, but amount of features which are supported in local stack is very different. I hit this wall every month where I see that, oh, these guys are not prioritizing this service at all. Well, okay, it's, or they can charge money for this service. Like a lot of serverless pieces on local stack, for example, they cost money, which is funny, right?
And do you use any static analyzer code for Terraform or like Chekhov tool for in your pipeline?
Well, I'm currently working on a project which is called compliance.tf, where I started looking into using tool like security static code analysis. Chekhov was the best one, but then as I went deep and deep understanding what it can do, I became a bit disappointed that yes, this is one of the best tool out there, but it's not in the state where I can trust output from this tool and say like, oh, if Chekhov says that this is failing, then it's really failing. There are a lot of ways how I can write Terraform code which will make Chekhov green, but code will be vulnerable. And this is very important to understand that there is no single tool out there in the market which you can run Terraform code and it will say like, oh, everything looks good. AWS has a lot of potential to make this tool kind of happening. They're working on this one, I know, but I'm still a bit unsure that the output from this tool will be 100% trustworthy. So that's unfortunate. But Chekhov is still the best one.
And
I'm sorry. Let's give others also,
okay,
possibility to ask questions. Sorry.
Thank you for your work. You partially answered my question, but wanted to ask about around 3 years ago, AWS actually Amazon wrote a post that they stopped using serverless and they saved like 90% cost moving to monolithic. So from your experience, maybe you can share like how do you know like it's time to not use serverless, like where is that set the line and moving to other solution, obviously on AWS.
Yeah, well, thank you. Your question is very relevant to the person who wanted to put 1 million lines of code into serverless. Maybe you need to talk together. But, this story about Amazon kind of moving away from serverless was misunderstood, to put it lightly. First of all, it's not Amazon, it's just one team, as far as I remember, with some video. Sorry? But yeah, Prime Video or something. But again, it's not Amazon as a whole. It's one team decided for their own benefit. Isn't it good, right? That we have option to choose what fits to us, to our needs, and what's not, right? So instead of common policy, like sometimes I see companies who say like, oh, we are all in on Kubernetes. Why? To host WordPress or what? Right? There should be always some clear indication that we do this because of this and this and this. And you should always have possibility to revise your decision and figure out that, okay, this part is actually exception, let's don't do this and this. But if you decided like blindly, let's put this into serverless, well, I'm quite happy that companies are able to change decision and move to ECS or EKS. I don't remember what they picked, but I like this very much. I wish I work with companies who are not as stubborn as like, oh, we use EC2 forever. Like, why? There are many different ways, especially now. So yeah, I hope I didn't answer your question. Yes. You're welcome.
And the last question.
So I just want to know your opinion on the acquisition of HashiCorp by IBM. So how did this affect the overall mood of the community and what's the future of Terraform in your opinion?
Yeah. Well, I was not prepared to talk about this now, to be honest. But I think that most people, I mean, I had this opinion since the very beginning of when they changed license, like in August last year or 2 years ago. The thing is that most of us should try to find the source of truth, right? When they changed license, why did they do this? Like, we can talk about this forever, like why they did change license or they're a bad company. Well, at the end of the day, it's their decision. We can argue about this. It's, yeah, competition, but again, it's a good idea to control your competitors, to my mind. Competitors didn't do pretty much anything which contributes to the Terraform development. Yeah, there was a lot of frustration being raised. Fast forward to the acquisition by IBM. IBM is not so bad company to my mind. I mean, there are worse companies. So that's, yeah, so I don't think it's going to be as dramatic as OpenTofu supporters believe. I like that there are a lot of changes happening in this field. But I don't think IBM is a company which will be able to just forget what, I don't know, half of internet is using to manage as infrastructure. I mean, half, I just put random number, but a lot of people use Terraform because they like the way it works and it was reliable. And company who was behind it has proven that it was reliable in long run. I don't know what IBM should do to make this bad, but yeah, I'm quite happy that the way it will be happening. If you want to learn more about CanITF, is a website where you can see that OpenTofu and Terraform they have a lot of differences already. And now when you say that we use Terraform, you need to understand that some features are not available in OpenTofu and vice versa. Yeah, that's pretty much it. I don't like to speculate on something what I don't know. I see that community is still very large. According to last survey, which I saw about a couple months ago, maybe 1 month ago, there were, I think, 10% or 7% of people who use OpenTofu. So it means 90% are still using Terraform. It's really important to understand that if you're not competing with HashiCorp, you are not in violation of any terms which they changed 2 years ago. Most of us don't compete with HashiCorp. We just want our stuff done. We don't resell it to other companies. So yeah.